Hello and welcome to York Observatory YouTube Tell-To, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. My name is Dorsa, and I'm joined by Marianna, Nakul, and Pouria, as well as Sunna and Tina up in the domes from AICO Observatory located at York University in Toronto, Ontario, Canada. YorkU broadcasts every Wednesday night at 7:30 p.m. local Toronto time. And for any questions or comments you have for our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on the Twitter or Instagram with the handle @York Observatory and Facebook at LNI Carswell Obs. We would like to inform you about the opening call for the applications for the summer 2023 Astronomer in Residence program. This program is a collaboration of the LNI Carswell Observatory with Killarney Provincial Park to host astronomers in the certified dark sky site of Killarney to lead in-person presentations and shows using the park's observatory. To learn more about the program, its requirements, and the application process, visit our website at yorku.ca/science/observatory/air. Good evening, everyone. I'm Dorsa, and we're here from the LNI Carswell Observatory at York University. Tonight, we've got a great presentation about the spring equinox and the astronomy of Nowruz, or the Persian New Year. But before we continue into our topic, we would like to say that the observatory at York campus is in Toronto, and we would like to welcome all of you to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Toronto has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalize our knowledge in this area. Welcome, everyone. Before we get started with our main show, we would want to give you a little update on what you can see this coming week and tonight. This week, we have the Moon, Mars, Capella, Betelgeuse, Sirius, Rigel, and many more stars visible. In the west, and at a setting time during sunset, we have the constellation of Aries and Perseus up. Regarding Aries, the symbol of this constellation represents ram's horns, which is not surprising since its name means the ram in Latin. Aries contains a few bright stars, Hamal as an example, that make up its shape. The famous Perseus constellation, on the other hand, is the 24th largest constellation in the night sky, with its brightest star being Mirfak, translating from Arabic word which means elbow, since it possesses such shape. Another famous star of this constellation is called Algol, or also known as the Demon Star, which is actually a variable star that brightens and dims regularly. In the southern west side of the sky after sunset, we have the Orion and the Canis Major constellations up, another set of famous constellations for having popular stars such as Betelgeuse and Sirius, respectively. The Orion constellation, named after the Greek word hunter, has 2 of the 10 brightest stars in the sky, from Rigel or Beta Orionis to Betelgeuse, also called the Alpha Orionis, indicating it being the first brightest star in this Orion constellation. In fact, this star is so bright that it is visible to the naked eye or on clear nights. Moreover, Betelgeuse, on the other hand, belongs to the spectral class M21AB, with M referring to the star's red color, and the 1AB suffix indicating that it is an intermediate luminosity supergiant. Betelgeuse has an absolute magnitude of -6.02, but an apparent magnitude of 0.58, becoming one of the beautiful targets of many observations with and without the use of telescopes. Canis Major, on the other hand, is a prominent constellation because of its many bright stars, including Sirius, or as we call it, Alpha Canis Majoris, which is the brightest star in the night sky in the optical wavelengths on Earth. A few facts about the star would be its visual brightness of -1.46 and it being a binary star in this constellation. It has a radius around 1.71 times that of the sun, with a surface temperature of 9,940 kelvins, which is more than 4,000 kelvins higher than that of our sun. Moving on to the moon, which is what you're seeing right now from the Allen I Carswell computers. It is in the first quarter with an illumination of 56.82%. So if the weather is clear for you guys, folks, there is a good chance that you can observe the moon clearly with a pair of binoculars or telescopes. The moon will be high overhead at sunset and will be visible until midnight when it sets in the west. Lastly, we have the beautiful red planet Mars up in the night sky too. You can locate Mars with the naked eye if you look at the south and west part of the sky after sunset and almost visibly located near the moon. This planet has been named after the Roman god of war and has two moons called Deimos and Phobos. Mars has a diameter of 6,779 kilometers, making it smaller than Earth, and has an apparent magnitude that reaches negative 2.94, making it quite less visible than Venus with an apparent magnitude of negative 4.14. That's all for what's up in the sky for today. I'll pass it on to my good friend and colleague Marianna, who is going to talk about spring equinox. Marianna, you can take it away.
Thank you, Dorsa. Now, to begin our discussion, I think it's fair to start off with the spring equinox, also known as the vernal equinox, and the summer solstice, or winter solstice in case you are in the southern hemisphere right now. So equinox versus solstice. The spring equinox of this year for the northern hemisphere was on Monday, March 20th, meaning that the first day of spring, astronomically speaking, was on that day. But what actually is the spring equinox? Well, the word equinox comes from the Latin word for equal night. So on the equinox, the length of day and night is nearly equal in all parts of the world. Hence, the equinox happens at the same moment worldwide, even though our clocks reflect different time zones. The spring equinox occurs when the sun crosses the celestial equator going south to north. This means that the northern hemisphere and the southern hemisphere receive roughly equal amounts of sunlight. Hence, neither hemisphere is tilted more towards or away from the sun than the other. The spring equinox signals the return of sunshine, warmer temperatures, and blooming flowers. However, for those in the southern hemisphere, it's actually autumn's arrival. So if the spring equinox marks the first day of spring, again, astronomically speaking, what is the summer solstice? Well, the solstice are the days when the sun's path in the sky is the farthest north or south from the equator. This means that 2 times a year, the positioning and tilt of the Earth relative to the sun results in the most amount of daylight time in the summer or the least amount of daylight time in the winter in a single day. The summer solstice follows the spring equinox and falls on Wednesday, June 21st of this year, meaning that the first day of summer, again astronomically speaking, is on this day. This means that for the northern hemisphere, the North Pole is tilted closest to the sun. That then implies that the southern hemisphere is experiencing their winter solstice. Thus, the longest day of the year is on the summer solstice and the shortest day of the year is on the winter solstice. In summary, the solstice results in the change of the length of day and night, while the equinoxes do not. The summer and winter solstice result in the longest and shortest days of the year respectively, and the spring and autumn equinoxes result in an equal amount of daylight and darkness all across the world. Now that we understand the differences between these two, I would like to pass it to my friend Nakul to continue our discussion.
Thank you so much, Marianna, for sharing some words on the spring equinox. It was interesting, by the way. And hello, everyone. I'll be going over the festival celebrated on the occasion of spring equinox, along with Nowruz, which is a Persian New Year, and some astronomical information about it. In many cultures around the world, the spring equinox is a significant event and cause for a great celebration, including special rituals to make way for spring, or coincide with a new year, bringing about labelling festivities. Holi is a festival of color, is celebrated across the South Asia, especially in India. During gathering and Shanban Novi are observed in England and Japan respectively, and Nowruz, which is a beginning of a new Persian year. Nowruz is a festival and a new year based on an Iranian solar hijri calendar on spring equinox. It is a traditional festival of Iran, and also it has been widely observed across West and Central Asia for at least 3,000 years. In this new year, traditional customs are followed, which include fire and water, ritual dances, gift exchanges, reciting poetry, symbolic objects, and more. The ritual of Nowruz begins around 3 weeks before the actual Persian New Year, starting with a throat cleaning of one's home to filter out clutter amongst belongings and to be surrounded in the new year with a healthy and clean space. On the day of the Nowruz, celebration ensures, including extensive visit and delicious dinner with family and friends. Children are gifted with sweet and money, and presents are shared all around. Nowruz is the day of the spring equinox. It marks the beginning of spring in the northern hemisphere, the moment at which the sun crosses the celestial equator. The day and the night will be equal exactly every year. Each 2008-20 years great grand cycle contains 2137 normal years of 365 days and 683 leap year of 366 days, with an average year length over the great grand cycle 365.242. This average is just 2.6 into 10 power minus 7 of a day, slightly more than 1 by 50th of a second, which is shorter than Newcomb's value for the mean tropical year of 365.242 days, but difference considerably more from the current average when an equinox year of 365.242 days, which means that a new year intended to fall on the vernal equinox would drift by half a day over the course of a cycle. And now I'm giving over Pouria, who will be talking more about the solar calendars and solar hierarchy. Thank you.
Thank you so much, Nakul, and hello, everybody. Thank you so much. I want to say thank you to Nakul for introducing us to Nowruz. Now it's time for me to talk about the solar calendars. In the world, there are so many different cultures around the world, and with that comes different calendars. Gregorian, Islamic, Jewish, Julian, Persian are some of the calendars that exist in the world. The first calendar that we will talk about is the Indian National Calendar, or the Sakha calendar. Sakha calendar is the calendar that is officially used alongside the Gregorian calendar in India. This calendar is also used in other regions such as Indonesia's Java and Bali Islands among Indonesian Hindus. A fun fact about Sakha calendar is that Nepal Sambat, which is the calendar used in Nepal, is an evolved edition of the Sakha calendar. Just like the Gregorian calendar, there are 12 months beginning with Chaitra. Chaitra begins on the spring equinox, just like the Persian calendar begins with Farvardin. This month is 30 days in length and starts on March 22nd, except on leap years when it is 31 days starting on March 21st. In this calendar, the names of the days are named after the 7 classical planets' native historical counterparts, starting the week with Sunday and ending it with Saturday. Now it's time for the solar Hijri calendar, also known as the Shamsi or Khorshidi calendar. Like as said before, like the Sakha calendar, Shamsi calendar begins on March equinox with the year being 365 or 366 days long. There are 12 months, and they begin with Farvardin, which begins on March 20th and ends on April 20th. And Farvardin is the first month of the year in Shamsi, and the year ends with Esfand. Esfand begins on February 20th and ends on March 20th. In this calendar, the first 6 months are 31 days, the next 5 months are 30 days, and the last month, Esfand, is 29 days. But on leap years, Esfand is 30 days. The ancient Persian calendar is one of the oldest calendars in the world, also being the most accurate calendar used nowadays. The reason for its accuracy and there being no errors is because of the astronomical positions used. Each of the months' names are taken from the ancient Zoroastrian calendar. Now that we are finished with all the information, feel free to ask your questions and we will do our best to answer your questions.
Well, everyone, you have been listening to the Alani Carswell Observatory's weekly Teletube broadcast, the Astronomy and Astrophysics program written and presented by the students, faculty, alumni, and friends at York University. The hosts this evening have been Tina, Sunna, Nakul, Marianna, Pouria, and myself, Dorsa. Make sure to leave any comments or questions in the comment section of the video and talk to us in the chat right now. We will be around for the next 20 minutes to answer your questions. All of our programs are free, but if you would like to make a donation, you can see our website at yorku.ca/science/observatory. You can always connect with us on the Twitter with the handle @YorkObservatory and check out our website for show notes, content, updates, and contact info at yorku.ca/science/observatory. Thanks for tuning in, clear skies, and have a good night, everyone.